Started my career, I would say about the education, I started with accountings. I then moved on to computer science. I did networking, automation systems, and I ended up with my PhD in quantum physics and thermodynamics, a diverse collection of study subjects. Now, amongst all these, I also did musical studies, but that's irrelevant. So today we're singing blockchain. I'm pretty sure, I hope, actually, that we've all heard of Bitcoin, the first blockchain that ever came out. Probably Ethereum as well, and there's more than 1,500 other coins out there, different blockchains, each one offering its own features or products, or it's a utility. Now, like these coins, there's more than 2,000 overall tokens based on existing blockchains. Whether those tokens are for investment, for equity, or utility tokens themselves, they're offering a feature, that's a completely different story. Now, the problem is blockchain is the most misunderstood technology. We've all heard the word maybe a dozen times, 20, 100, but do we really know what it is? That's actually the biggest question I get. What is the blockchain? Does anyone in this room knows what the blockchain is? Raise your hands. You mind enlightening us? Give me a term.
Blockchain is a ledger, basically. It's a continuously expanding ledger of economic transactions.
That is correct. And the basic term that you will find going around, it starts with, it's a distributed ledger, and I'll continue with blah, blah, blah. It doesn't mean anything to a businessman. It means a lot to a software developer, yes, we make sense of that term. But it doesn't actually describe what you can do with it on a business level. Now, we're going to see in a bit the mechanics behind blockchain, how it works, and I hope that will enlighten you enough to generate 6, 7 figures or more valued ideas. Now, if we stick to terms though, I'll give you mine. Blockchain is an append-only, always online, oxymoronic data structure. Now, don't worry, we're going to analyze every single part of this sentence. I'll start in reverse. Data structure. It is effectively a data structure. Similar, yes, to the traditional databases we use today in software and platforms, but it has very specific and unique elements and differences than the traditional databases we know today. Now, going backwards, I'll start with the first one, oxymoronic. It's a very weird word. It's very rare as well. I was first acquainted with the word about 2 years ago, so don't feel shy if you don't know this word. I'll explain what it means for those who don't. It's two terms that are contradicting each other, basically. They're oxymoronic. It's like saying jumbo shrimp. Doesn't match. Or, I hope we don't have any Microsoft officials in here, or we say Microsoft works. It's oxymoronic. The same happens with blockchain. The data that it keeps, they're both transparent. Everyone can see the movement that happens in the blockchain. It's a dynamic ledger, like we've seen on the first terminology. But it also has privacy involved. So transparency and privacy in the same sentence, and you will make sense of what I mean by these two words in a bit. So it's oxymoronic. It's always online. Now, unlike the traditional systems that we build today, if I'm a bank and I should always be online, what do? I build my software and I have a number, dozens of servers serving it, and then I have database servers separately to keep my data, and I have backups of the backups of the backups. And still there is a chance I will have downtime. Now with blockchain, that doesn't happen. There is hundreds of thousands, and if we're talking about Bitcoin or Ethereum, the bigger blockchains known today, they have millions of computerized equipment spread around the globe, serving them. So it doesn't really matter if one of them, or half of them, or most of them, by that matter, go down or they get disconnected. The blockchain, as long as there is not just one, we need a few. As long as there's a few of them online and connected, the blockchain is alive, it's accessible, and it's available to the public. Now, the most important term, it's an append only. You can only record data to the blockchain, that data structure that we spoke of. And once they're recorded, the term says they are immutable. You cannot change them, you cannot delete them. They are eternally recorded, and they cannot be overwritten either. So an append only, always online, oxymoronic data structure. That's what do we know today about it. In order to continue this, I want you to forget the word currency. We're going to talk about the blockchain as a technology. Yes, it's being used in the cryptocurrency world as we know it. It's got its ups and downs, and it's nowadays about $300, $400 billion industry. It moves all this value. But let's forget the word currency. We're going to see if it applies to your own business or industry. We're going to see, furthermore, if it's better than your existing solution or any existing solution. It's not always better with blockchain. That's why I mentioned in the beginning, it's a misunderstood term. A lot of people use the word blockchain because it's trendy. They launch a project and they say blockchain. And people believing in it, heard the word blockchain is trendy, they invest, and eventually they might lose their money. Blockchain itself is disrupting actually the largest industries of this planet, from music, finance, healthcare, education, and we're going to see some examples at the end. Now, if I go beyond, I mentioned this planet. We're planning to colonize Mars. I'll give you an example. I was actually a candidate for the Mars 1 mission, believe it or not. So let's move forward. In 10, 20, 50 years, when we do eventually colonize Mars or any other planet, and we start commercing, how on earth are we going to send money to Mars, may I ask? We're going to load big bags of cash and ship them up in a rocket-fueled bomb? I don't think so. So we need a solution that's digital, that's virtual, that's dynamic. And that's where we need to know where we need to innovate. What are the problems that we're facing today, whether that's for the financial market or anything else. So we're going to go forward and see what's behind, what drives, how is it built, and what can it do eventually. Before we do that, I need to get you acquainted, if you're new to blockchain, with some terms and terminology that we use. First thing you're going to hear a lot is miners. Miners are basically big, ugly machines that serve the code. I mentioned the blockchain is a data structure. It's a software, effectively, that drives and commands what happens with this dynamic data. So it cannot exist in thin air. So we need computerized equipment. They are called miners, and you will understand in a bit why the term miners or mining is mentioned. Then the next term is transactions. If you've dealt with any cryptocurrency, like Bitcoin, Ethereum, and a number of others, you may have came to terms with this word transactions when you basically hit that button that says send, and you want to send X Bitcoin to your friend, to a company, to wherever. That's called a transaction. It's not approved the moment you press send. It's not valid yet. It's basically a broadcast, not a transaction. It's a broadcast of your wish to transfer that amount to the other side. And it will be approved, we will see in a bit. Those transactions, those broadcasted messages, can also, unlike the Bitcoin blockchain, which is simply transactional, the rest, newer blockchains, 2.0, 3.0, and we're now developing even 4.0 blockchains, can carry with it data. And that's where all the magic starts. This data can be either publicly available, or they can be privately held and be unlocked with special keys. So you can rent data, you can sell data, and get paid for it. All these transactions and data that goes through the blockchain are stored in, we call them blocks. They're basically data containers. They are encrypted, there is cryptography involved, they're linked to each other, linear, and that's why the term blockchain. It's a chain of blocks, of containers with data. Now, rewards, I will come back to. Blocks, basically, every new block that gets added comes back with a reward, and that's actually what fuels the whole network. That's what gives the incentive to miners. I mean, I have computers, I have machines. Why should I serve the blockchain? I get rewarded for it. And eventually, the most important part of blockchain is we need a usage. Because if we don't have a purpose and it's just for being there and saying blockchain in our project, then it doesn't have any value. So let's jump right through it. This is a sample, a sketch of a blockchain. It's not an actual blockchain. But you can see the blocks we mentioned in software. We start from 0. There's actually 9 blocks. So 0, 1, 2, 3, and they're all linked with each other. In a very specific form, they're linked to each other. Each block I mentioned is encrypted. So it has, let's call it an encrypted ID, known only by the next block. So B1 up there knows the encrypted key of B0. So they're effectively linked together, B2 to B1, and so forth. So if in blockchain, we have the so-called wallets. That's my ID, my account on a blockchain, any blockchain. So if I have X value in it, and I want to send it to wallet 2, I hit that button that we mentioned earlier, called sending basically my broadcasted message. I want to transfer X amount of Bitcoins, Ethereums, or whichever coin I'm sending to the other side. Now, this message is broadcasted to the blockchain code, which runs on what we said, the mining machines, these big, ugly machines that look beautiful to any tech head like myself. These miners, in turn, they ask constantly back to the blockchain code, hey, boss, what have we got to do? Is there any work to do? And the blockchain gives them. It gives them the basket of pending transactions. They don't get to pick. They get randomly allocated transactions. And also, the blockchain instructs them that we are now on block number 8. So all you miners need to be building block number 9. And they do. They all start building block number 9. Now, there's a problem here. We only need one of those blocks. Imagine there is millions of these miners built in block number 9. But I only need one of them to be the next block that gets added to the chain. So what happens there? There is, in the blockchain code, something called the difficulty algorithm. It's a huge, big mathematical equation that's so difficult to solve. And because of encryption as well, it cannot be solved by following A plus B multiplied by X, Y, Z. You can't follow that and find the answer. It's mostly guesswork. So we guess the answer. We say back to the blockchain, is it 1? No. Next guess, is it 1,350,000? No. And we continue until we find the right answer. This difficulty, and I'll stay a bit on it, adjusts itself. Because if we add more miners, if I had only 2 or these 5, I would give them a small difficulty. So, because I need blocks to be found, I need them to find the answer at X intervals. Now, while they grow, they become hundreds or 100,000 or millions, then we need to increase the difficulty of this. Now, moving forward, one of them, let's take the scenario that this guy found stroke gold. He found that answer. What happens then? The block that he had gets the right to be added to the blockchain, and it comes back with a reward in the form of precious cryptocurrency. That's what we said fuels the network. He gets it, so what happens to the rest block 9s? Simple. We scrub everything, we delete everything with it, and we start over with block number 10. Now, that's more or less how blockchain works. If we move on to the miners, which is a very important part of blockchain, a bit of history. Bitcoin, back in 2009, you could mine it on a personal PC, and you could probably make hundreds of Bitcoins in a day. Today, you need larger computerized equipment, and it would take you a year to make that amount. That's because the difficulty rises the more miners that come in. If you want to see how it looks like having a mining operation, this is a fire hazard at somebody's home. The next one is a more tidy home operation. In industrial, I'm personally involved in an industrial mining facility, and this is how it looks, more or less. And for the last picture, I fired the photographer who took this. He didn't get the right angle to see the rigs behind it. He focused on us. Now, the second most important business element of blockchain is the applications where it applies. You can build solutions, or you can enhance existing solutions that were previously impossible because of the specific format that it covers. We said it's append-only. No other database does that. We need to do that in the software. And when we come down, if we know what PCI compliance is, I might add a small example. PCI compliance is for processing credit cards, and you need to pass some validations that no one has access to the data, no one can sell the data, no one can delete stuff. So imagine if we approach a PCI compliant officer and tell him blockchain is effectively PCI compliant by birth. He might throw us out his office because he will lose his job. Moving on to some of the solutions. One of the biggest elements, the biggest strengths of blockchain is aggregating data. And this is where I hope you will start generating ideas. The process is called tokenizing, and I have some examples. I'll give you some use cases that we had in the recent years. First one is hire go, and there's another one that's related to cars. I'm talking about tokenizing cars. The second one was called car vertical. There's a third one similar, I don't remember the name. What do? They tokenize cars. They don't put your car on the blockchain, they put its data on the blockchain. HireGo puts the hiring process, so you can have your car rental wherever you go on your mobile phone. Car Vertical does something much more effective. If let's say BMW or Mercedes, if they cooperate with Car Vertical and you buy a car directly from BMW, they record that purchase. They record the car you bought, what are the features it has, what extras it came with, date of manufacture, the whole lot. And then you go for a service, and they record that as well. You might remember, anything recorded is immutable. No one can tamper with it. So you have a full service history of your car proven anywhere around the planet. You can sell it in Singapore, and you have proof that you've properly maintained it and claimed top dollar. Brilliant solution on that one. I'm not sure on the next one, the land and property. There has been word about India. I've read an article planning to integrate blockchain into their land registry department. Basically, who owns what and where? Brilliant solution. No mention of the word currency. Let's remember. Now, what does that do? It provides easy access to any researcher, evaluations, studies about what property is owned and where, what's the prices that go up and down. And on the other side, you can transfer the title deeds at the push of a button, paperless. Moving on. Gambling. Now, the biggest problem in gambling is, and many other industries, but gambling is the biggest, is they're often accused of cheating or having tricked machines or slot machines, or their games are tricked and they cheat the gamblers. Now, that's what Gablica does. If all the records are publicly available, what goes in, the whole, let's call it lottery, goes on publicly. The code of that blockchain is public and visible by anyone. Hundreds of thousands of developers can see it and make sure that it does what it says on the box. Then no one can accuse them of cheating on that one. MediChain, one of the best projects I've heard, and a good cause as well. They record the patient's data. The patient has the private keys to unlock and see his data. No one else sees it. I get to choose if I want to give it to a set doctor by unlocking it to him. But also, anonymously, all the data is consolidated, aggregate, we said, and they can be used in research by several labs to develop new medicine or anything else related to diseases. Also, to control viral diseases, because they have access to where something occurred. They have access on the blockchain without knowing who they are. Moving on, copyrights. I'm sure you remember Kodak in the old times, Kodak and Fuji in the film industry. Fuji slightly died on the film industry. They do now, I think, thin film solar panels. Kodak somehow survived in the digital revolution, and they recently launched a copyrights blockchain, effectively recording the IP rights of the artist who owns the photo, the graphic, the illustration they did, and they have the options to either sell it permanently to the new owner or rent it for a limited time, and get paid for it. While on the other side, if there is a discrepancy, it's all proved on the blockchain, and it can be used actually in court. We haven't had a case yet, so it's yet to be proved. AI, I will end up with. Blockchain and AI is actually the best match, because if you think of it, blockchain records data that's immutable. You cannot delete them. So it's effectively very similar to how the human brain works. If we learn something, we cannot unlearn it. We can simply train our brain by learning the opposite of that 100 times, and that's the power of habit. So we don't erase, we overrule. It's the same thing that happens when you pair up artificial intelligence with blockchain. We mentioned a number of industries. There is hundreds of ideas. I mean, one thing that I haven't seen yet is an accounting system based on blockchain. Not sure it exists yet. It might. But that is also a best match, because in accountings, the FSA rules say you cannot delete an invoice once you issue it. Effectively, that's what blockchain does. We have to now do it in the software to prevent deletion of an existing invoice, and many other rules that the financial services applies. So an accounting system with blockchain would be the best match. So to end up with, I hope you're cranking out some ideas now, whether it's for a personal problem, your business problem, something new, or effectively enhancing something that's already there, an existing solution, making it faster, bigger, more efficient, more economic, cheaper. And eventually, if you're not into the innovative mode, you can just be a part of it, share with the community. It's a brilliant community. You can share your ideas, your problems. Someone might pick up your problem, create the solution, and eventually they will sell it to you. You get the solution you always wanted. And if you like the projects that you see out there, you can invest in them and hopefully make some profit from those ones. So at the end, what's your idea? And what are you going to do about it? I think we have some time for Q&A. How much time do we have? 5. We have any questions on what we just described?
Hello. Thank you. Very nice talk. Who is setting the rules, for example, level of difficulty? Is there some body, some group, company, private sector, public sector? How does that work?
Thank you for that. That's a brilliant question, actually. Blockchain as a code is effectively and usually open source. That means it's publicly available. Someone wrote it. The first one was the so-called he, she, or they, Satoshi Nakamoto. He just published his code, and it can be reviewed by anyone. It's built in. The difficulty is built into the code itself to auto-adjust based on how many miners are connected. And the existing, every rule that exists in blockchain, what's a valid transaction, how do we verify everything, is publicly available. And it does what it says on the box. It's not down to one man. Yes, please.
What do you think the quickest solution would be to the energy consumption when it comes to mining?
to energy consumption.
Yeah.
That is, in fact, the biggest problem we're facing today. It doesn't only relate to the energy that we consume, because I've shown you some of the computerized equipment we use. I'll give you some rates. One of them could generate, say, on Ethereum, about $700, $800, $900 worth of value per month, and it spends on the other side anywhere between 120 to 150 euros of electricity per month. It is said that to generate one Bitcoin by the year 2000, it will cost more than $1 million or something in electricity in a certain period. So that is the biggest problem that we're facing. There has been some solutions with renewable energy. Like in Iceland, there is geothermal energy, and one of the biggest, if not the biggest, mining facilities is based there. I've seen others myself. We personally use some solar energy to cut down on costs, but switch to the grid in the night because batteries haven't been developed yet that are affordable. So scaling the blockchain, when you have too much usage, that means you require more equipment to scale up and be effectively processing more. So power is one of the biggest problems we're currently looking into how to solve. It's the biggest cost. It's said, actually, I have a fact that mining, all the blockchains that are being mineable, in China, uses about 6% of their entire electricity load, in China alone. Anything else? Yes, please.
Yeah, can you please explain what a 51% attack is?
51% attack. I will start by explaining a bit what consensus is. I mentioned before that we need a few machines to be online in order for the blockchain to be uncorrupted and online. Why do we need a few? We saw the blockchain on the blocks on the top. Every machine that's connected knows that. It knows the series at those blocks. It knows everything. Basically, everyone knows what everyone else knows. So we have consensus. If I change something on a previous block, myself, I have a mining rig, and I tweak it to change something. I want to double spend. I want to add something else to it. Nobody else knows that. They already have a previous record of the exact same blockchain without my part in it. So I get disqualified. Now, a 51% attack, if we have 3 miners only, we just started the blockchain, okay? 3 is the wrong number. Let's say 10, 11 miners. And we just started this blockchain. If one of us acquires access to 6 of them, that means he has more than 50% of the network of that blockchain. So he, effectively, can actually alter, in some cases, parts of that blockchain. And that's what a 51% attack is for. Thank you for that. Thank you very much. And I hope to hear your ideas fairly soon.